we need to talk about rate of change because we're going to see the rate of change in a bunch of your physics experiments as well as some of your biology labs. So, rate of change. Rate of change sometimes goes by another name that some of you may have heard. That name is slope. When you think about slope, usually what you do is you think about a line. And so you think about the rise of the line over the run of the line. That's how steep the line is. Or another way you might remember thinking about it last year in 8th grade was the change in y over the change in x. That's a handy way for finding the slope of a line, but today we're going to focus on the rate of change more as what it represents than what it looks like graphed. We're still going to think about it as a ratio, but this time we are going to look at it at the ratio of the change in the dependent variable over the change in the independent variable. So you can see that our ratio has a lot of similarities to the two that we talked about with slope, the rise over the run, or change in y over change in x. We're still looking at change. We're looking at the change in the dependent variable and the change in the independent variable. So we need to know what is a dependent variable and what is an independent variable. Think about the words independent and dependent. What do they mean? Independent. When you think about independence, maybe an adult, living alone, getting to make decisions, being in charge. When you think about a dependent, you think about a minor, somebody who has to listen to the parents. I use that analogy because that sort of is related to how the independent variable affects the dependent variable. The independent variable is the one who is in charge, gets to make the decisions, and the value of the independent variable affects the value of the output or the dependent variable. So this is the one that changes a lot, and it depends. The independent variable is usually the input into an equation or a function. The dependent variable is usually the output of an equation or a function. So usually I think about the dependent variable as the thing that you calculate. Had a hard time spelling that. Sorry about that. And the independent variable is the thing you put into the equation to find the calculation. So let's look at a couple of examples where we can see the change in the dependent variable over the change in the independent variable and find that rate of change. Alright, so here we have a graph of some data. And this is data about maple syrup. It looks like here on the x-axis we have amount of sap used, and on the y-axis we have the amount of maple syrup made. So before we can actually find the rate of change, we need to think about what is the independent variable and what is the dependent variable. So the IV, the thing that's in charge, or the thing that you put into an equation, that would be the amount of sap in this case. The amount of sap determines the amount of maple syrup you can make. So the maple syrup is the dependent variable. Alright, so now in order to find our rate of change, we need to find the ratio between these two things. We need to find the change in the maple over the change in the sap. On our graph, we're given two data points. We have the data point 66 and we have the data point 120 and 12. Well, since we're looking for the change in the maple right now, let's focus on the maple. Looks like it's here, 6. And then it moves all the way up here to 12. So the maple went from 6 to 12, and it changed by 6. So the change in the maple was 6. It went up 6. Now, the bottom of our ratio for the rate of change needs to represent the change in the sap used. So it looks like the sap used started here at 60, and then it went up here to 120. So we used 60 gallons between those things. So we made 6 quarts of maple syrup. That was the change in maple syrup. And 60 gallons of sap were used to do this. We can simplify our rate of change a little bit more. We can, let's see, we can take out a 6, right? We can divide by 6, so we have 1/10. So 1/10, 1 quart of maple syrup per 10 gallons means our rate of change is 0.1 quarts per gallon. We get 1/10 of a quart for every gallon of sap we use. This time we're going to look at a table, and this time we're looking at the difference or the change in time and the change in distance. So if we're looking at this table, we know that our table usually goes x, y, so this sort of gives us a shortcut to finding our independent and dependent variable. The independent variable, the thing that's in charge, is the x, or time. So the bottom of our ratio is going to be time. The dependent variable, or the thing that you calculate at the end, is the y, and so that's distance. So our rate of change is going to be distance over time, or if we want to use units, and Mr. Fawcett will want us to use units, we're going to do miles per hour. So unlike the maple syrup example, we don't have a graph, so we don't know if the rate of change is always the same. So we're going to need to look at each individual change or each individual entry in the table. Now, I always like to start with my independent variables and my dependent variables then with little x or little hatch marks. This helps me remember I'm finding the change between these two things. So if we look at our time, we change from 0 to 1. That's a change of 1. I went up 1. I change from 1 to 4. Change of 3. We go up 3. 4 to 5 is a change of 1. 5 to 8 is a change of 3. And 8 to 10 is a change of 2. Now we have to look at those distances. They don't change quite as nicely. 0 to 35. How do we change there? We increase by 35. 35 to 71, we increase by 36. 71 to 82, the increase is 11. 82 to 199, so we went really far in that section. We went 117 miles. And 199 to 200 is just a change of 1. So we can see that all of our rates of change are not going to be the same. So let's find a few of them. The first rate of change I'm going to look at is the one between 0 and 35. We know that the change in the dependent variable was 35, and we know that the change in the independent variable was 1. So in this case, we had 35 over 1, or 35 miles per hour. Now if we look at the next set, we had a change of 36 for our dv over a change of 3 for our iv. So that means our change was 36 divided by 3, 12. So our rate was 12 miles per hour. What happened to our rate of change? It went down. We were going pretty fast, and then we slowed down a little bit. I'm going to clean up my board, and then we'll do the last couple examples. All right, it looks a little bit better. Let's look at our next set. Our change in the dv was 11. Our change in the iv was 1, so our change was 11 over 1, or 11 miles per hour. All right, then we end up with 117 and 3. So that ratio is going to be 117 over 3. Which is 39 miles per hour. Looks like we're getting fast again. And one last change we need to look for. We have 1 and then 2 hours. So we certainly didn't get very far. We got 1 mile in 2 hours. So we were just half a mile per hour. Another way you can think about this is 0.5 miles per hour. So the rate of change is the dependent variable, or the change in the dependent variable, over the change in the independent variable. All right, so here we have Anne. Today Anne has $50. And after working for 3 days, she will have $410. If we want to find the rate of change for Anne's situation, the first things we need to do is we need to find what the independent variable is and what the dependent variable is. Independent variable is the thing that's in charge, and dependent variable is the thing that you calculate, the thing that gets changed. So if you think about Anne's situation, she's working, she's making money, what would you calculate? I would probably calculate my money. The money depends on the days, so the money is the dependent variable, and the days are the independent variable. That means when we actually find our rate of change, we're going to find the change of the money over the change in the days. So let's read Anne's situation again. Looks like Anne has $50 right now, and then later her money becomes $410. So we need to find that difference. How much did her money change? It changed by $360. Now we need to do that over the change in the days, and it was 3 days, so it's over 3. So her rate of change is 360 over 3. 360 over 3 is 360 divided by 3. So her rate of change is 120. Now remember, it's money over days, so $120 per day. All right, let's look at one last example. This time we're looking at Oscar and the book that he's reading. Looks like we have days and we have pages remaining. So first we need to figure out which one is the IV and which one is the DV. So again, think about what you would calculate. If you were Oscar reading a book, you would probably calculate the pages. The pages you have left depends on how many days you have been reading. So when we find our rate of change, what are we going to put on top? The pages, and what's going to go on bottom are the days. So let's look at our data that we have. 3 days, 200 pages. 6 days, 150 pages. So let's start with the pages, the change in the pages. I had 200 pages, and then I had 150 pages. So I went down by 50 pages. Now we're going to look at the days. We were at 3 days, and then we were at 6 days. So we went up by 3 days. So the pages remaining is negative 50 over 3. And we can simplify that fraction a little bit. It's not really simplifying so much as dividing. Negative 50 divided by 3 is going to get us negative 16.7 approximately. So the pages remaining is changing, going down by 16.7 pages per day. So remember, when you're finding the rate of change, you need to find the change in the dependent variable over the change in the independent variable, and that ratio will tell you the rate of change for your situation.